Hello everyone. Today we will work together on one sample t-test using SPSS. Before we jump to SPSS, let's talk about one sample t-test as a definition. So what is a one sample t-test? A one sample t-test is used to determine if the mean of a single sample is significantly different from a known or hypothesized population mean. An example scenario for this in real life. For example, we are checking if the average test score of students, a group of students, differs from the national average. To perform one sample t-test, four main conditions have to be met. Number one, the sample is randomly selected. The dependent variable is continuous, that is numeric. The population for which the sample is drawn is normally distributed, and the sample should not have extreme outliers. For example, if for some reason one of these conditions is not met, the alternative will be a non-parametric statistical test that we will talk about in another video, and we will talk as well in other videos about how to test normality in SPSS, but not today. So one sample t-test has two hypotheses. The null hypothesis, which states that there is no significant difference in the means between the group and the population mean, and H1 states that the sample mean is significantly different from the population mean. So this hypothesis can be two-tailed test or one-tailed test. Two-tailed test in case we are testing if the two means are not equal, and one-tailed if we are testing that either if the sample mean is greater than the population mean, or the sample mean is smaller than the population mean. To interpret the results of this test, we take the p-value. If the p-value is below 0.05, we reject H0 and we say that there is a significant difference between the two means. And if p-value is above 0.05, if p-value is above 0.05, we fail to reject H0. In this case, there is no significant difference between the two means. So for our exercise today, null hypothesis says that the average height of a grade 9 students, we have 100 students in grade 9, the average height of a grade 9 students is 160, and the alternative hypothesis states that the average height of a grade 9 students is significantly different from 160. So because it's just does not equal, we don't have a greater or smaller in our alternative hypothesis, we will be using two-tailed test. Let's talk now about the data that we will use to perform this analysis. It's a data of two columns. The first is the student ID and the second is the height of students in centimeter. And this is our numerical variable that we are interested in comparing its average with the population average. How to perform this analysis in SPSS? We go to Analyze, Compare Means, One Sample t-test. We drag the height to test variable. In the test value we type 160, that is the value that we are testing, and we make sure that we checked the estimate effect size to test the strength of the significance in case there is a significance. We press OK, and we end by three tables: the one sample statistics, one sample t-test, and the one sample effect sizes. To make the interpretation more clear, I have copy-pasted the tables from SPSS to Word document and made the interpretation here. So as to the first table, the one sample statistics table, sample size is 100, sample mean is 161.484, which is slightly higher than 160, standard deviation is 4.54, which indicates the variation in students' height. There is a variation between the students in height. The one sample t-test table, the main important value here is the sig-to-tailed. The p-value is 0.001, which is below 0.05. So we reject the null hypothesis H0 and conclude that the average height of students is significantly different from 160. On average, these students are 1.484 cm taller than the hypothesized mean. And the last table is the one sample effect size table. If we look at Cohen's D value, it's 0.327. This indicates a small to moderate effect size, and the rule of thumb here that it is small if it's equal to 0.2, medium if it's equal to 0.5, and large if it's equal to 0.8. I hope this video was beneficial for you and hope to see you in another video.